Hello! This is a video explaining why it's taken me so long to solve the mass production of my Will It Make It to Area 51 mini Jeep USB sticks, and also how I've solved mass production of the silicone tank tracks for the tank track conversion. The purpose of this video is to show why it's taken me so long to send them out to people that have been okay waiting for me to solve mass production. As always, anybody that's wanted them sending out immediately has had them sent out using much slower, clunkier methods. But in order to stop me going insane, a lot of people very kindly said, we're okay waiting for you to solve how to make these easy. Because if I had to do all of them the slow way, I was going to go insane. The other purpose of this video is to help out anybody that's trying to mass produce 3D printed parts, or just mass produce anything in general, and they're struggling with quality control, how to make them reliably, and how to make sure that the customer's always happy because they get what they want. I've learned a lot trying to make sure, and I've actually cracked it now, making sure that everyone gets what they want. And the third purpose of this video is, when I first started making these little silicone tank tracks, I was gravity casting each individual one by hand, and it basically damn near broke me. It was taking 3 hours plus just to clean out the molds, to reset it and to cast more silicone, and then it was taking about 4 hours for the silicone to cure. So basically 8 hours per go. You can maybe do 2 a day if you do it when you first wake up, and it was a catastrophe. I couldn't do it, so I had to solve mass production. And I can't imagine that I've invented this technology, but as far as I can tell, I have. So I've solved silicone spin casting, which allows me to cast 10 at a time, and I can cast 5 of these at a time, so I can make 50 at a time, and the reset time of doing it has gone from 3 hours down to 12 minutes. And I know that because I put a 12-minute pizza in the oven, set a timer, and I managed to remove these, reset it, and set the new ones casting before my pizza timer went out. So if you're only interested in silicone spin casting, jump to this timestamp and you can see that. Otherwise, this is just going to be a journey down my path to insanity of how I've solved mass production, and now every kit that goes out is perfect. So without further ado, let's go. First, we'll talk about the 3D printed parts, and we will begin with the wheels. And these are the wheels that mount on the axles. They have to turn, but they also have to grip the axles and stay together. Now, the important thing about this is that the wheels have to grip the metal axle, right? Now, you can't make the hole too small, because then when you put the axle in, it will actually gouge the hole. Then every time you put it in and out, it will get looser and looser until eventually it doesn't grip. So what you have to do is you have to calibrate that hole perfectly so that it just grips the metal, and it's literally squeezing it. And that is just through compliance from the plastic. The hole is just ever so slightly small, and it grips it and it doesn't wear. So in order to solve this problem, first thing you do is you make the wheel about the right size, and so it looks correct. Just play around with it so it looks aesthetically okay. Then you have to play around with how large do you make that hole. Now, the way that I like to do these things is once you work out, so this is an 1/8 of an inch aluminium axle, because I'm in the USA, so it's 1/8 of an inch, 3.175 millimeters. Make the hole that size. 3D printing, holes are never the exact size. There's a slight tolerance. So the way that I prefer to do things is get your perfectly sized hole that would be ideal, but you don't know what size it's being printed as. Then print 10 different sizes, so there's 5 larger and 5 smaller. And what that will tell you is that if you, let's just say that this middle one does grip it, you don't know quite how well it is and how close it is to failure. Because if this is the size that you printed, and if it's only the tiniest bit larger, then it would fail and the axle would just fall out. You don't know that because this one seems to work. But if you find that this one, this one, this one, and this one all work, you now know, okay, well actually I should make it this size because that gives me the tolerance. So if my print ends up being a bit bigger sometimes and a bit smaller other times, it will still grip it. And so by working out the band that works, I will go for the halfway point, because then you've got some tolerance. Because this hole will change size depending on the filament that you buy could be ever so slightly different. You know, maybe there's something in the batch. The filament, if it has humidity in it, it will then swell, because as the filament heats up to 220 degrees Celsius, water moisture will boil, and that will then make it bubble slightly, so the hole could end up slightly smaller. Room temperature could make a difference. There are all of these, there's loads of things which could make that hole vary ever so slightly. So if you pick the middle of the range, that gives you a lot more flexibility. So once you've worked out where you think works, then print 20 of them at a time. Print them on multiple printers over multiple days with multiple weird little variations. You know, close the door on the printer, keep the door open, see if any of it fails, and then that will give you a data point. So say, for example, if the room is very cold or it's drafty, then it fails. You can either know, okay, right, never have the room get cold or have a draft, or maybe I need to change the size of this hole. Maybe you can find an edge case, which happens fairly often. So yeah, print 20 on one plate. Make sure that all 20 of them fit perfectly, and you can take them on and off like 20 times. And this is like the 10th take of this, and this still grips. So I know I've done it right. Yeah, multiple plates, multiple days. Find out what makes it fail, even if it's slightly ridiculous, because it's a data point. Then, once you've got this sorted, now you need to make sure that they actually print correctly. And I print 100 of these at a time. Sometimes I print 150 at a time. Now, you can't reliably visually inspect 100 of these wheels individually and spot a mistake. You just can't do it. But I can't. Don't have the attention span. Things will slip through. So what you do is that you hack the human brain. Humans are very good at spotting mistakes in a repeating pattern. So what I do is I line up 100 of these wheels perfectly in a 10 by 10 grid, and then I pause the print after the first layer. And my smart home system sends me a notification to my phone and tells me, I've just paused the print, come and have a look. And I then have a look, and you can instantly spot if there's a mistake. If there's a mistake, turn the printer off, scrap the print, start again. It's not worth it, because if that one failure, you forget which one that failure is, and you take off the wrong one off the board, a customer gets a wheel that's incorrect, and then somebody in Belgium asks me to send out new pieces, which I will, and now all of a sudden, the one lot of postage I would pay for that is more than a roll of filament. So yeah, just scrap it. If they all look good, press resume, then it will finish the entire print over the next 9 hours, and then you have 100 wheels, and you can now pick up that plate and you can easily spot mistakes. And then if you do that, that will then tell you if any of them are wrong, and hopefully they're all good, and then you rinse and repeat. Yes, use this technique for every other mass production 3D print that you are doing. Don't try and fight the human condition, embrace it. Line them all up perfectly and you can spot mistakes. Then, once you've got this plate of wheels, I then choose to put them in separate boxes. I've got lots of empty filament boxes, and they're in batches. And I do randomized testing. So when I come to box up all of these mini Jeeps and I send them out, I will personally check 4 or 5 out of maybe the 100. And if they're all perfect, then okay, cool, carry on. If one of them's wrong, work out what went wrong, maybe throw out the batch of 100 wheels, because it is not worth sending somebody the wrong thing. And yes, that is 3D printing. And now we're going to solve how to reliably cut axles. Each mini Jeep needs 2 wheel axles and 4 track axles. And that means that when each mini Jeep needs 6 pieces of aluminium cut to 2 different lengths, and you've sold quite a lot of them, you need thousands of pieces of aluminium, all cut to exact lengths. Now, I contacted a lot of workshops and tried to get quotes for getting these mass produced by them. A lot of places didn't want to touch it, and those that did were quoting me thousands of dollars or tens of thousands of dollars just to chop bits of aluminium. And I thought that was ridiculous, so I had to build something myself. And so this is a $200 Vevor metal shear from Amazon, and I'll show you how it works. This piece of metal goes in this hole here, and then it slides through until it hits this bolt. So it slides in and it hits that bolt. And this bolt, if you wind it in and out, so if you wind it all the way in, makes a piece of metal shorter, wind it out, makes it longer. There's a lock nut to hold it in place. And so basically, if you push your piece of metal in, and then you pull this lever, it will chop it off at a certain length. Ta-da! And you do that a lot more. And, of course, you need to make sure that all of these are going to be compatible with the model. So what you do is you put the bolt at a certain position, chop it, measure it, does it work? If not, adjust it. Once you get it so it's right, chop 10, test all 10, then have a cup of tea, do something different, get a different frame of mind, come back, chop another 10. If those 10 are correct as well and they all work, then you can go into mass production. Now, when you are producing them using this method, you have to push in the rod and then pull the lever. Every now and then you might cock that up. Maybe you don't push it all the way in, something goes wrong. Don't worry, I've devised a way to spot any which have been cut to the wrong length, and we'll get to that later. And now it's time for things to start getting really complicated. We're now dealing with the actual USB chips that have to go inside, that contain the actual video files. First problem is that you would think that buying them directly from the manufacturer, like this, by the hundreds, would be the cheapest method to do this, wouldn't you? Just in a tray. But no, the cheapest way is to buy them individually packaged in plastic and inside this little shell, which you have to take apart, and you end up with hundreds of these things. I can show you just how many of these I've taken apart. Here's the USB stick. I'm now going to look this way, and that is it, taken apart. I've done this a lot, and it's about half price, and it saves me hundreds of dollars to do them this way. So I have to buy them, I have to shuck them, and then I end up with just these chips. So what you do is that you have your video files, which you know are all correct, and then you program these. So you program one, and then you put the files on it, and you read them back, and you make sure that it is a perfect copy. There's like 64 billion zeros and ones, and you have to make sure that all of those are exactly correct. Once you've got that, you read it, and you then write it to a file, and it's saved, and it's just one file, and you know that that's perfect. Then you can plug in 16 of these at a time into a computer, and you can write that file to all 16 at the same time, and then read back all 16 afterwards and make sure that what is on there is correct. Because sometimes these are fake, and that's happened to me. There was loads that were 8 gigabytes pretending to be 64. And the only way you can find that out is by reading it back. So this also makes sure that nobody can get sent a faulty one. Because if you read back what's on them, you know it was on there. So if you plug more than 16 at a time into Windows, Windows runs out of letters of the alphabet for the drives. And then Windows just starts to crap its pants. Also, when you're writing 16 devices at the same time on the same USB bus, that saturates the bus, and it then takes, it's about 17 hours to program 16, so 1 hour per drive. So I run 3 computers in parallel, all programming 16 at a time. And so that's how you program those. Then you will discover that whatever size they make these circuit boards changes. So you can see here that these are different heights. So the first problem is that where it slots into the mini Jeep, you need to make the slot the correct size. So now you need 2 different sized mini Jeep bodies to allow for the 2 different USB sticks. then you'll discover that they're all different thicknesses because they put different chips on them. And that's actually a thing that on my design, where the axle holder goes over the chip, if the chip's too thick, you can't fit the axle on. So now you need multiple size axle holders for multiple sized chips, which have multiple sized mini Jeeps. And you need to keep track of this. And I do that just by having long stick, long stick, short stick, and then thick stick, thin stick, and then there's a medium stick. And basically you just pick the right ones at the right time, and in theory it all works. And once again, when you're bagging them all up, make sure that you do random checks every 30 or so. Take a kit apart, make sure you can assemble it, disassemble it, put it back in the bag, and you know that you haven't done something stupid. There was something else. Going mad. So when I say that these are different sizes, this is all of the different designs of chip which are compatible with a short stick mini Jeep and a Type 1 axle holder. But all of these are different designs, but all of those are compatible with one type of body and one type of axle holder. So now when I get one of these silicone sticks and I need to see which one it goes in, I can have a look and okay, right, it's none of those, it can't be this one. I find the correct one that it matches, and I know then that all of those silicone sticks go with which mini Jeep body and which axle holder. Yeah, for the love of God, don't try and do this because it will drive you insane, but yeah, it's a complete catastrophe. Okay, so that's the silicone sticks, and so now we're going to go on to bagging up all of these individual components into the little baggies, making sure that everybody definitely gets the correct amount of parts, and also that the axles have been cut to the correct length, because I invented kind of a clever way of doing that. So now we'll go to the bagging station to make sure that everything gets bagged correctly. Welcome to my living room, or sweatshop number 2 as it's now known. After many cock-ups of having to open up these baggies because I'm not sure that inside it contains the perfect amount of parts to assemble a mini Jeep, I have finally solved how to make sure that what is in here is the exact amount that is needed. And here's how I've done it. So you count out 10 bags, and then you count out enough pieces to fill 10 bags. So 10 USB chips, 10 USB covers, 1 seat, 20 wheel axles, 40 track axles, 40 wheels, 40 track rollers. And then you go through and you take the correct amount of parts to put in one bag, and it's written in a nice big number so that you know, and it starts with 1 and then increases, and it just helps your brain just keep everything in track. Then, when you get to the end and you filled your 10th bag, if you have any parts left over, you know that you've underfilled one of these bags. And so the worst that happens is that if you only put 9 seats in, for example, and then you get to your 10th bag and you're missing one, then all you have to do is you have to look through 10 baggies that you've already bagged up. So the problem is limited to a very small amount. Now, counting out 10 seats and 10 windscreens, that's fine. But when you have to start counting 40 wheels, that is quite time consuming and is also quite open to error. And you really don't want to have that error if you can avoid it, because if you were to count 39, for example, by accident instead of 40, and you were to then only put 3 wheels into one baggie, you wouldn't catch that mistake. So what I've devised is a way to make sure that you always count out 40 of something or 20 of something, and this is how I've done it. So, say for example you want to put 40 wheels into there, because it's 4 per baggie, 4 times 10 is 40. Best way to do it that I've found is you 3D print this little funnel, and what you do is you put the wheels in there and you give them a shake so they all go flat, and then you shake them like this. And you throw one over the floor, and then you keep finding them in your socks for the next 2 months. And then what happens is, wait, I nailed that. That is 40. Let's say that there was a couple more. You would be able to spot them. They're not in line. So all you do is you get rid of those extra ones, put them back in the box. And so this is 40. And now you put a little hole in the funnel, and that must be 40, unless any fell on the floor during that process, and you can hear, always work on a hardwood floor, then you know that 40 are in there. Those are the wheels. Now, the axles. And this is where it starts to get quite tricky, because you need to count 40 of these things, which are very fiddly, and put 40 into that box. Also, you need to try and see if you cut any of them wrong, because I am not measuring all of these with a pair of calipers. So, what I've invented is this little 3D printed tool. It magnetically clips together, like that. And then what you do, this is quite difficult for me to film, but see if we can give it a go. You pick up a handful of these, and you do this. And you keep doing that until it's full. Because it's magnetic, you take that off, and now you have counted 40. And if any of them stick out too much or stick down too little, you know that they must be the wrong size. You can also just quick visually inspect and make sure that all of these line up. These ones have a little bit of a tolerance. It doesn't really matter too much, but too short is a big problem. You can see that all of those are correct, and you can just tip them out. This was an extra feature that I put in because I thought I was going to distribute like 4 into a bag like this. This is now superfluous, but I designed it, so I'm going to try and at least get some credit for it. And then, and that is how you put them in there. And because I'm doing it on camera and I did it badly, 2 of them missed, but you get the point. This is how to count 20 wheel axles. Come on. There we go. And there we go. That's 20 wheel axles. They must be correct. Tip those in, and there we are. That means that you get to solve making it faster, making it reliable, and spotting any mistakes. And all that remains is 40 track rollers, which I will now do now. This does still need some refinement, but it does work. I'm still trying to solve exactly, some of them fall weird, but basically you do this. And I found if you sort of sweep them, there we are, not bad. And there we are. That is 40 of those. That is enough parts to bag up 10 perfectly. If you have any parts left over, you know there was a mistake. And by the end you should have 10 in there. And then when you've done 10, you then put them into the bag, because you really don't want to go searching through these to find if you've counted something incorrectly. And now, the silicone tracks. Okay, so silicone tracks. Everything up to this point wasn't actually that difficult, and I could have pushed through just using pure determination, just counting out parts. Yeah, it's going to take some time, but I could push through that. However, the silicone tracks were a completely different kettle of fish. When I first started out, I was casting them one by hand. So this is a mould, right? I might do a close-up of this. So this is a mould, the 2 halves bolt together, and you pour the silicone in one side into one funnel, and then it comes out the other funnel, and you leave it for about 4 hours and it cures. That's not so bad. You have to pour them into all of these, but you can do it. It takes you about half an hour to pour them in. Yeah. The problem is, once you come to take the moulds apart and then take all of the silicone tracks out and clean them, the reset time is over 3 hours, and I just couldn't do it. It actually was driving me insane. So, what happened was, a friend of mine, William Osman, he runs a YouTube channel, William Osman. He does brilliant videos. I think my favourite was the one where he adopted a raccoon to see if he could, be compatible with having kids. Anyway, so you can tell he's about as mad as I am. He said, why don't you try spin casting them? Where you have basically a mould which is hollow, which has lots of tracks on it. You inject the silicone inside the mould, and the centrifugal force flings it to the outside, And then you don't have to take anything apart. You just keep it spinning for 3 hours, turn the machine off, take the tracks out that have now cured, and then just squirt in some more. And I thought, yeah, okay, let's give that a go. So I began my quest of madness. So my first version was I resin printed a mould which just had 2 tracks inside it, so I didn't waste too much silicone. And basically I went round to my friend Pierre's house, I clamped it in his lathe. So spin casting version 1 is pot of silicone and syringe into mould spinning on Pierre's lathe. Hopefully not throwing silicone all up Pierre's wall. Cut to Pierre shouting at me. Whoa, excellent camera work, Ed. It's almost like they invented tripods for this. Right, top 10 things that are going to go wrong, and it's this. Fire in a hole. This is such a bad idea. Did that work? First version, after 4.5, 5 hours, it still hadn't cured. And it was like quite gooey. And I couldn't work out what was going on. But then I thought, his workshop is a bit cold, it's the middle of winter. So, cleaned it out, got it ready to go again, and then I got a heat gun and a heat lamp, and I used my thermal camera, and I stood there like a moron for about 3 hours, trying to heat it up just enough to keep it about 30 degrees Celsius. Any hotter, and it could be a problem. Too cold and it was going to take too long. Thank you, Pierre, cameraman. This is version 3. Okay, slightly uncured. Oh, that's not... yeah. Yeah, it's still like a gummy. But... right, well let's... and it still didn't cure properly. It was just staying all gooey and gummy, like inside, and just wasn't curing. But the stuff that was in the pot next to it had cured perfectly. So why is it that when you spin it, it doesn't cure? And I was thinking, is it vibration? Like what's going on here? Is it G-force? There's something that isn't working. So I tried it a couple more times. Same thing happened every time. I printed one in clear resin so that maybe I could get some more information. No, same thing. I thought, I mean, this resin doesn't inhibit the gravity molds from curing, so I couldn't work out what was going on. And basically, in the end, I came to the conclusion of it must be the vibration or the G-forces stopping the silicone from curing. Probably the vibration, because when silicone cures, all of the bonds interlink, and then it forms a solid, basically. And so I thought, okay, maybe the slight amount of vibration is stopping it from curing. And I basically gave up, and I just consigned myself to a life of misery, doing these for probably the next 6 months. And it was a pretty sad time, but I sold them, so I had to make them. Then, a very good friend of mine came to stay for a week, and he's a mechanical engineer, and we were going to go off playing in the desert, and on the first day, he got here a bit late, and so he said, is there anything we can do in the evening? And I said, if you want to go insane, and you can share my misery, you can help me clean these 50 moulds out. And so he said, yeah, fair enough, like a good friend does. After we were about 3/4 of the way through it, he said, yeah, no, you can't keep doing this. It's going to drive you insane. This is soul destroying. We need to solve spin casting. And he was like, well, if we can't solve it, then, I don't know who can, Me and him are normally a pretty good team for solving stupid ideas. And so I told him what I was doing. And he said, what speed are you spinning it at? And I said 1,700 RPM, to get it to fling out. And he said, I don't fully know the maths off the top of my head, but that seems a bit too fast. And I said, no, I've done the maths. That's about 3G. So three gravities of force flinging the silicone out into the mould in all directions. Because we're on Earth, so we've got 1G. So if you have less than 1G, when the mould turns over, it would all just fall down. So you need more than one. So I thought 3 is a nice safety factor. So he said, run that maths again. That doesn't seem right. I ran the maths again, and Alex was correct. So on Earth, we have 1 G, which is 1 gravity. Right? On the surface of the sun, and the sun makes enough gravity to hold the Earth near it and stop it from pissing off out the solar system. On the surface of the sun, there is 22 G. Right? I did the maths. I was subjecting my silicone to 69, nice, G. So 69 G, so over 3 times the gravity on the surface of the sun. Alex's initial theory was that I was spinning them too fast and I was maybe separating part A from part B of the silicone, because you have to mix them together. So he thought maybe with the G-force we were separating the 2 compounds. When he realised that I was subjecting it to 69 nice G, I think that I was actually separating the individual silicone compounds within the silicone. And so he went, right, do the maths properly, moron, so it's 3G. And it came out to, I needed to do, I think it was 340 RPM instead of 1,700. So by this point, I'd built my little robot, or a test robot, because I was trying to solve the problem. And just using a short mould, one of these, I have many, many, many moulds. Thank you, Formlabs, for sending me all this resin. I just did a short mould, and I spun it at 340 RPM, and I think we had a pizza and a beer, and then after 3 hours, turned off the machine. Please work, please work, please work. And it was obviously shorter than this. In fact, there might even be one of them. Yeah, it might have even been one of these. It came out perfect. It was absolutely perfect. It cured all of the detail was in it. There was no like gooey gummy stuff. And yeah, it was absolutely amazing. You cannot imagine how happy I was that it had solved itself. And all that remained to do was that when you put the silicone inside and it gets flung out, I made individual ridges so that it would fill up one of the chambers for the track, and when it had enough silicone inside it, it would flow over into the next one, and then into the next one, and into the next one, and eventually, when it had completely filled it, any excess silicone would get flung out of the machine. It would go over the floor, and so I now have lots of these, which is the silicone where it lands on the floor and you peel it off of the floor. So the thickness of your silicone part is the size of the track, like volume, plus surface tension, because it has to build up and flow into the next one. And it's like when you have a bucket of water, you can actually fill it up so that the water is actually higher than the lip of the bucket because of surface tension. So it took about 3 or 4 different molds, and they would take 13 hours to print each time. But eventually I managed to dial it in so that at a known speed with a known viscosity in a room of a known temperature, the silicone would flow into the next channel, and with that little bit of surface tension it would come out perfect, and that is what these are. And so I will now show you the robot that I made. Here it is. And so you have a power supply there, and when you turn that on, it spins this motor, which you can control with a knob, which is in this absolute pile of chaos. So you turn that knob, and it adjusts the speed that this motor spins at. And that motor has a belt, which turns the first mould. That mould then has a belt that drives the second, and then the third, and then the fourth. There's about to be a fifth. And what you will see is that there's one motor that end, and one motor that end. And that has to happen because the friction of turning all of this is about 12 to 15 watts per track. And so what happens is, per track mould, And so what happens is that you have to put 15 watts in to turn that. To turn that, you now need to put in 30 watts. To turn that, you need 45, which means that poor belt has to do 45 watts of power. And so, by putting a motor at each end, you get to split the difference, and it works, and it doesn't stop. It doesn't start skipping. And yeah, when you turn these, the bearings initially do get a bit hot because of the mountain of shit on the floor. My bearings have 2 rubber seals in them to keep all the dirt out. You do get friction from those, and using my thermal camera, I could see that they were heating up. So you pop out the seals, you take the grease out by washing them in an ultrasonic degreaser, and you just put some little machine oil in there, just so it has a little bit of lubrication. It's not really doing any work, so you don't need to, keep them. So goodbye. And yes, that is the machine that solved my sanity. And also the last thing, in case you're wondering how I make them. I'm gonna die. In the edit, it has just occurred to me that I haven't actually shown you how I cast them, so we're gonna do that quickly. Okay, so you need to mix your silicone, and it comes in 2 different bottles. This is bottle number 1. You need to mix 50-50. So I know that this needs 80 grams. So that is part 1. Then I need to mix in 1% of black dye, which is in this syringe. Whatever the stuff that in this syringe touches is black and ruined forever, so be careful. 0 the scales, and so I need 1.6 grams of this. Tits. Right, okay, well, that's 1.1%, that's fine. And then 80 grams of blue. It's not blue, but it's in the blue bottle. Okay, 80 grams. Then you try and zoom out on the camera without covering it in blue crap. So we're going to try and zoom out. Then you use your little mixing robot that you got off Amazon, which is probably one of the favourite things I've ever bought. You turn it on. You lower it down. Then there is a little timer on it. And you press the button. And it will mix it for 3 minutes. Then you raise it out. Then you put it in the vacuum chamber. And this then sucks all of the gas bubbles out of the silicone. Then you depressurize the vacuum chamber, and now it is time to put the silicone in the machine that makes me happy. So, to do this, you plug it in first. Ed, you're an idiot. Power supply on. Turn on. Machine. Make sure machine is running at the correct speed by using the cheapest RPM counter on Amazon, which uses a laser. And you point it, actually, I'll show you. On one of the drums there is a laser target, which if this laser points at it, it will read how many times it goes past it per minute. That gives you how many RPM. So you turn it on, you point the laser dot at it, and it should be about 400 RPM is safe. Yep. Yeah, about 400 RPM. Cool. We know the machine is good. Turn that off. Then, remember the silicone is currently curing. Drop down the camera on a tripod. Lower, lower, lower. Because hopefully I can show this going in there. Good luck, Ed, and his awful camera work. Right, inject it in. Is that working? Maybe. Okay, I think you can see what's going on there, right? And in the time it takes me to do all of the rest, this one should fully smooth out inside, so we are going to hopefully, if the first one didn't capture on camera, show this. So I cocked up the filming, but hopefully you can see inside there is a perfectly smooth silicone tube which has actually given a reflection. It's such a good smooth surface. And we now let this sit for about 3 hours, and after 3 hours turn it off and we'll remove the spun silicone. Okay, here we go. It's been 3 hours. Turn off the machine, and then in order to remove it, you just peel it down slightly with your thumbnail, and then using a plastic doodah, go in and you sort of pop it off, then rotate 180 degrees, do the same the other side, pop it off, and then you use the technique I have devised, which is the circular wiggle, and it just lets go, and there you go. 10 perfect tracks, and all you have to do is just put it in that jig and then cut it off. And this has made me very happy. And the last thing that you have to do is you have to turn a thing which is 10 tracks into each individual track. And so I made this MacGuffin. It's 4 quarter circles on a shaft, and when you tighten these two ends, Mummy, when I tighten this, you should be able to see this, it forces them apart on a piece of threaded rod, right? And so, and you slide the track over, and you turn these two things towards each other, and what happens is all of the pieces of plastic expand. It has now gripped the piece of plastic. And then you can use a scalpel blade and you just run it around it, and you can cut them all, and it's all held in one place. If you try and use a pair of scissors on this, it won't work, because if you go slightly off, you'll cut the track. So that was the final thing that solved my sanity. And yeah, I've had to make quite a lot to solve this project. So that solves the mass production of my Will It Make It to Area 51 USB sticks. I'm sure this has rambled on for far too long, and I'm sorry if it's bored you, but it's probably 1% of the anguish that I've felt trying to make it so that I can produce these at a rate so that people can actually get delivered what they paid for. And if you are one of the people that said you were okay waiting, then I hope that this has helped explain why it's taken so long, and thank you so much for being patient. As always, anybody that had a birthday party or Christmas or whatnot and needed it sending out immediately, did get it sent out using the old clunky method that drove me insane, but don't feel guilty. Thank you very much. And yes, so I am now going to edit this video, and I will then do some more 3D printing, and I'm probably going to cry. So cool. Thank you.